Isn't that the cutest thing ever? If you go to the SF Zoo, you can actually see one. That is the world's largest aquatic rodent. It's a capybara. And ask me sometime if you're interested in why one of the tools we're about to introduce is called Capybara. So we're going to introduce Cucumber and Capybara, which I think are probably, if I had to pick one tool or technology in this course that is sort of the coolest single one, if I had to put all the others aside, this is the one that I would pick to keep. So what's the big idea behind Cucumber? If you believe that these sort of 3x5 index cards plus mockups, user stories, are a reasonable way to come to agreement with the customer, because you can describe in plain language what the feature is supposed to do, you can draw simple pictures about it, then you can actually get two different kinds of tests out of that information. One of them is just testing whether the code you wrote for the story functions correctly. And the other one is one that essentially simulates what the customer themselves would do if they were using the feature. And sort of by definition, if you kind of went through a storyboard mockup saying, OK, if you click here, you see this, and then if you fill this in, you should see this. If you can do that process, but automate it and capture it in a test, and that test passes, then by definition, the thing you stepped through with the customer behaves the way the app does. So it's an acceptance test in some sense, as well as an integration test. What I love about Cucumber is that it kind of bridges this gap between the customer and the developer. The thing about a user story is because the user story itself is not code, you can't use the story as a test. But if you could convert the story somehow into code, and that were the test, then the story would actually give you some satisfaction that you're doing the right thing and doing the thing right. So Cucumber essentially lets you rewrite your user stories in a language that is somewhat restrained. It's not like totally freeform, but in some sense it is much closer to English, or for those of you in TV land who program in another language, it is much closer to a spoken human language than it is to a programming language. Cucumber scenarios look a lot more like prose than they do like code, which is one of the reasons they are so useful on both sides. So let us show one. And I'm going to, before I show you an example scenario, I'm going to give you a disclaimer. The scenario that I'm about to show you as an example is valid. It works. I will demonstrate live coding, like I'll run it and show you that it works. And then I will tell you that you should not write scenarios the way that this one is written. But for the moment, let's use it as training wheels. Here's an example user story. And like we said on Tuesday, an example of a simple feature for our Rotten Potatoes movie database is the user can manually add a movie. Right? So that's the feature, the general functionality that we want. Here is one scenario that would illustrate that feature in progress. So this is actually a list of steps that it's almost like a script, right, that a human being could follow if they were using the app. And if they follow this set of steps and they step through all of the screens, then this is what should actually happen. So here's my simple Rotten Potatoes app, which you've all seen before. I'm going to compress the window here so that we can see both the window and in the top half of my editor. OK, so on the top half of my editor on the right, that's the exact set of steps that was on the slide. So if I follow it like a script, right, given I'm on the home page, which I am, when I follow the link for add new movie, so if I scroll there, there's the link, I follow it, then I should be on the create new movie page. Look at that, indeed I am. If I fill in the title with Men in Black, and I fill in the rating as this, and I press Save Changes, then I should be back on the home page, which I am, and I should see Men in Black somewhere on the list, and there indeed I do. Okay, so it's quite literally, this format is a script that describes what the human being interacting with the app would do if they were exercising the feature manually. And by the way, just to prove that I have nothing up my sleeves, the file that I was just showing, this one is called addmovie.feature. And if I actually run that, which I'll show you in a minute how it works, I always start with bundle exec, as we've said so many times. Green, 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 green. Every green line is my test actually interacting with the real app through the same mechanism as a browser would. It is basically, from the app's point of view, indistinguishable from a real human with a real browser, except that, of course, it works much faster than a human would. So for the rest of today, what we're going to focus on is what's going on there, what makes it happen, and why is it cool. What I just showed is an example of a feature. A feature is the kind of thing that would come out of a customer meeting, such as, I would like to be able to have it so you can manually add a movie resource to the database. The feature will turn into some number of scenarios where each scenario is basically an example of the kind of thing I just showed, a list of steps that somebody would follow that in some way exercises part of that feature. Now, the version that I just showed is kind of the most straightforward thing you can imagine. That's the version where I do everything right. I don't try to type in a movie name that has illegal characters in it. I don't accidentally hit the delete button instead of hitting the save button. So things that, if everything goes exactly according to plan, and with real users it rarely does, then I proved that that version of the story works. For reasons that should be obvious, but we'll talk more about in a minute, we call that the happy path story. Scenarios, typically some handful of steps. Why would a scenario not be a much larger number of steps? If you had a scenario that had 20 or 30 steps in it, what does that imply about the user story that the scenario is based on?
It's not specific.
It might not be specific enough, or even simpler than that, it might just be too big, right? Small stories are good stories. You can always take a big story and break it down into nice pieces that are individually testable, but if it really takes a sequence of like 20 or 30 interactions to express the story, that story is probably already too big. The part we haven't seen yet is what are called the step definitions. So for every line in that story, given I'm on this page, when I fill in this, each one of those lines somehow needs to be turned into the actual code that makes those things happen in the app, that stimulates the app externally to make it react the same way as if a human was doing it. So we'll talk about step definitions in a moment, but just a little bit more on what the steps look like, the individual steps in the script. In general, there are sort of 3 kinds of steps, but 5 keywords that talk about them. There are steps that begin with given. They talk about what the state of the world is assumed to be before the story happens. So maybe the story involves sorting the movies according to some order. Then clearly, one thing you would need to specify before is, OK, well, which movies already exist? Because then we can talk about what it would mean to sort them correctly. So what is the state of the world prior to the thing that I'm trying to test? When steps are the actual thing that I'm trying to test. The user does something, and the effect of the user doing something is what's exercising the functionality of the story. Finally, there's then steps, which is after the user has done something, some other condition should be true as a result of that action. Something has changed, for instance, or something is displayed. So the then steps are typically checking if the post conditions are true. And you may also see keywords and but. So then I should see this on the page, but I should not see that on the page. Or then I should see this on the page, and I should see this on the page as well. Okay? What's interesting is that in the actual user story, these are all aliases for the same method. So to make that concrete, if I went back to my example story here, and this is actually, if you remember, this was the contents of the actual Cucumber file, which we're going to explore in more detail in just a moment. If I changed every beginning of line word here to the word given, it would not affect the way the story behaves. If I changed every one to the word then, or to the word but, or if I just randomly chose the words given, then, when, etc., and I randomly picked which one should begin every line, it would not change the behavior of running the test. So my question is, and it's not a clicker question, why bother? If it's all the same in terms of how the test runs, why are there different keywords for different types of steps? Because clearly, they aren't really different types of steps if the keyword doesn't make any difference. So why? Yes?
So the user, the person testing, understands.
Yes, so the user, and by the way, in this case, user is not just necessarily the customer, it's also you. So that you, when you're reading this story, can actually mentally keep clear which steps are things that I'm going to assume to be true, which steps are actually exercising the app, which steps are checking if the post conditions are correct. In fact, if you write your scenarios well, which in a moment we'll talk about what a good scenario is, the scenarios become documentation. I actually, just a couple of weeks ago, I was dealing with one of my own customers that uses the app that I showed you a tracker for. And they had an obscure question about some feature that it had been like a year since I looked at the code for that feature. I actually didn't remember how the feature was supposed to work. But I had some really good scenarios that basically said, given the customer starts from this state and does these things, here's what should happen. That was documentation. That allowed me to remember, right, now I remember what they wanted that feature for originally, and now I can verify what the feature is supposed to do. Now I can go answer their question. So scenarios are super valuable. And this is the other reason we've had students ask, and for a while there was a sort of internet war going on about, as we'll see, Cucumber itself is really just kind of a front end. It lets you write these nice stylized things, but in the end, you need actual code to make the test go. So for a while, there was a question of, well, if you need code to make the test go, why not just have that be the test? What is the value of having this sort of layer of sort of cutesy-looking English sentences over it? That's the value. It's documentation. The customer can read it. It's not technical. And as the developer, it reminds you of what you were thinking. So those are the 5-step keywords, all aliases for the same method. And now let me ask my first question. Again, not a clicker question, just a let's think about it question. I showed you an example of the story of adding a new movie manually. And I'm now asking, why is that scenario that I just showed you insufficient by itself to claim that we have tested the user story about the user manually adding a movie? What are some things that we really need to be doing if we want to claim to have a test for this, but that we have not done using that simple scenario that I showed you? What could go wrong? Yes? Only includes the happy path, right? That's one thing, is that I've not checked what happens if the user, for example, tries to leave the movie field blank. That would arguably be something you'd want to prevent. So there are various ways the user could misuse or accidentally screw this up, and I have said nothing about how we test those. What else? And just as a reminder, I'll put the story back up. After I have filled in stuff, and let's assume that we filled in legal things, we save changes, then I should be back on the home page, which is the page that lists all the movies, and I should see the name of the movie. Anything else missing? Anything else I should see? Say again? I should see the other movies, that's true. Let's assume we have a test somewhere that I didn't blow away the other movies, but what else? I mean, I filled in a title and I filled in a rating. Where am I checking that the title and rating I filled in actually were correctly saved? Right? I'm actually, in this example, I'm actually not. So in fact, not only does it only check the happy path without checking the sad paths, it also doesn't really fully check the happy path. The only thing that says in the test is I see the name of the movie back on the home page. And yes, that is certainly important, but if this was a real test, I probably would also want to check that the title and rating information are consistent with what I put in, not just the title, but also the rating information. So it doesn't even do that. Pretty weak for a test. And it doesn't check the sad paths at all. So we'll talk about how to resolve those things, but the moral of the story is that typically one user story becomes various Cucumber features. What the customer thinks of as, oh yeah, let's be able to add a movie manually, that's going to turn into quite a bit of testing. And I'm going to elaborate using a feature that I developed last year for my app, which is the ubiquitous, if I forget my password, is there some way that I can log back in? I happen to hate the secret question approach because I don't remember like what my favorite color was in 3rd grade, but whatever. That's what they wanted, so that's what I did. So the feature from the customer's point of view is, could you do the thing where if you forget your password, it lets you answer your security question? And from the customer's point of view, that's legitimate, right? They've probably used a lot of sites that have that. So from their point of view, they probably think they're being pretty specific about what they want. For me, I was able to turn this into a handful of scenarios, like if the customer answers their secret question correctly, it logs them in. If they answer it incorrectly, it doesn't log them in. If they have never chosen a secret question with an answer, then they can't use this mechanism to log in, right? The explicit thing use a secret question for login recovery, that came from the customer. The customer never said these things, but these are implicit. They logically follow. If the customer wants that, then these are some cases we have to consider. And in fact, even here, we haven't gone far enough, because this just talks about if they have or don't have a secret question, then maybe these are the scenarios. But we haven't even talked about how they could get a secret question. So there's that. That has to become, oh, by the way, happy paths, sad paths, right? So we haven't even talked about what happens to set up that secret question, because clearly, the happy path here and this first sad path story, they both assume that somehow the customer has set up a question and answer. So I got to do that one too. I need a separate feature, which is how do you set up a secret question? And again, that's going to break down into a handful of scenarios. The happy path is the customer can establish a secret question. Possible additional one would be if somebody has logged in and they have not set up a question yet, then they get the little reminder saying, would you like to set up a security question? And that also means that, OK, if they already have a security question, then they shouldn't see the reminder. So you get the idea, right? The only thing the customer said was, can you do the thing where the security question lets you log in if you forget your password? And that sort of leads to this tree of requirements. So the difference between the customer meeting and the team meeting is really that. You come out of the customer meeting with, I want the security question feature. The team meeting is, OK, well, that implies that we've got to do at least a couple of these different features with multiple scenarios. And this is the granularity at which you're going to do points, right? Because now you're getting from what the customer said they want to the nitty-gritty of, OK, what are the specific interactions we have to implement in order for that overall feature that the customer said to really work? OK? What questions do you have about this? Again, most of this is not rocket science, but the systematically thinking it through and going through this entire process of outlining the features and the scenarios before you write any code is a strong predictor of being able to actually deliver something good at the end of the iteration. Onward? I'm assuming we're going on. OK, so what have we not talked about? So far, we've only talked about what did the story sort of look like. And we've got these 3 kinds of steps and so forth. We have said nothing about what makes those stories become runnable in a way that actually interacts with the app, just as if the user were doing so. So that is next. And in particular, really in all kinds of steps, but in the when and then steps, what we really need is something that interacts with the app the way that a user would through something like a browser. We can say that it sort of pretends to be a user and steps through the scenario. And Capybara is that tool. Capybara is super, super awesome. And in fact, most of the heavy lifting of tests that you write with Cucumber is really done by Capybara. So Capybara is a library that provides what in the business we will call a headless browser. That means that internally, it does everything a browser can do. It can make requests. It can parse HTML. It can create a data structure representing what would be on the page. It can execute JavaScript, and it can have JavaScript interact with that data structure. The only thing it doesn't do is actually pop up a big window and display the page. Although, as we'll see, you can force it to do that if you really want. So for all practical purposes, Capybara library allows you to interact with the app, kind of like what we were doing with curl, where instead of having an interactive browser, we have a command line. This is like curl on steroids. It can do all the same things with the responses as a full-blown web browser would do. And in fact, it tends to be based on the same technologies that web browsers are based on. So how do you, oh, sorry about the weird, that's a nice little preview. So what's the connection between the steps of the script, given, when, et cetera, and the step definitions, which is the actual code that makes things happen? This is the magic of regular expressions, which I'm sure you all know and love. And if you were just waiting for an excuse to get back on top of your regex foo, that opportunity has now arrived. If you weren't waiting for that opportunity, it still has arrived because you'll be in a world of pain without regexes. But basically, what happens is when Cucumber is running a test and it sees a line like this one, like I picked one of the lines from my simple example, I fill in title with Men in Black, it will look through a bunch of files in my project that contain step definitions, and it will look for some regular expression that could possibly match that. Here's an example of such a regular expression. It looks a little more complicated than it really is. In particular, don't worry about the initial question mark here. This is a fancy notation, which means that the I is optional, and if it's not there, it's fine. It won't be captured. But the important bits are these bits. So since you're all regular expression masters and mistresses, can someone remind me, when you have parentheses as part of a regular expression, what are they used for? Parens in a regular expression?
Capture group.
Capture group. Whoever said that, double thumbs up. Capture group means that if the regular expression that you're comparing the string against actually matches up, then the parts that match that happen to be between parentheses will be remembered. And in this case, we've got two sets of parentheses, so we've got two capture groups. Will this regular expression, in fact, match the string? Here's a hint. I probably wouldn't be putting it up if the answer was no. I'm not going to do it just to mislead you. But so that you remember, and I will send out the name of a website called Rubular, which is a great place to practice regular expressions in Ruby, although the syntax is basically the same in all languages that have them. This says, I'm looking for 0 or more occurrences of anything that is not a double quote. And here again, I'm also looking for 0 or more occurrences of anything that is not a double quote. So this entire regular expression matches as follows. The word when, got that? The beginning of the step, so caret anchors a regular expression to the beginning of a string, $sign anchors it to the end. Believe me, you're going to see a lot of this. So don't worry if you, again, don't write all of this down. You'll absorb it by osmosis or by drinking from the fire hose. So I, optionally, yep, there's I. Fill in, fill in. Quote, quote. Any sequence of characters that is not a quote, that's the word title, followed by another quote, there it is. With, and then same deal. Open quote, any number of non-quote characters, closing quote, end of string. So two things happen here. Thing number one is those two match. It is the case that the regular expression matches against that string. The second thing that happens is the pieces that matched that were enclosed in parens are going to be assigned to two capture groups, and Cucumber arranges to make them available as arguments to a block, an anonymous procedure that is the body of the step definition of any Ruby code. If we look at the actual step definition that matches this, and we ask, what does the code do? It does this. So what was the step definition supposed to express? That there's a field on that web form called title, and I'm going to fill in as the value that a user would type into that field the string men in black. Those two get captured, and they get passed to this method called fill in, and it takes one argument, which is the name of the field, and a hash argument that is the value that the field should be filled in with. This is one of a great many super useful methods that Capybara gives you. What this means is, based on the most recent page loaded from the app, find a text field that has this name, and fill that in as if the user was typing with this value. Super, super cool. So this is what I mean when I say that the heavy lifting is really not being done by Cucumber. Cucumber gets you as far as saying, I'm going to look at the steps in your script, in your scenario, and for each one, I'm going to try to find a step definition whose regular expression matches. And when I find it, I will execute whatever the body of the definition is, and I conveniently allow you to capture things that were in the original step and pass them as arguments, basically. Right? That's the essence of what's going on here. So what kinds of things would you expect to find in the body of a step definition? Well, one kind of thing is if there are preconditions that your test depends on. For example, if I was writing a test that depends on a number of movies already being in the database, I can imagine that there would be a step definition where I'm going to make some active record calls to create those movies, because I need to make the state of the world look the way that my test expects or assumes. What else might be in there? Well, calls to Capybara, and at least two types of calls. One of them is calls like this, where it simulates the user doing something. I fill in a field, I follow a link, I click on a button. The other type is one where you're not changing the page, but you're inspecting. So when we had that last step that says, then I should see so-and-so on the page, Again, we can ask Capybara, look at your internal representation of the page and see if this string occurs somewhere on the page. And as you might expect, you can actually get much more specific than that. You can ask, does it occur within a particular div or within a particular element? Is it the case that a drop-down menu contains or does not contain a certain choice, or that a certain choice is actively selected? So basically, anything that a human being could do in a browser, whether it is asking a question about the page or doing something that changes the page, if a human being can do it, Capybara can probably express it. So anything that you can imagine you manually doing a test for your app, you can use Capybara and Cucumber to create an automatic version of that same thing. And that's the way that you think about this high-level sort of testing. So what's the anatomy of a step definition? It begins with a keyword, although like we said, given, when, then, they're all actually equivalent. And that's true in the step definition files as well as in the Cucumber file. But again, we try to use the one that most closely matches the intention. So if the step definition is usually used to set up preconditions, probably it makes the most sense to call it a given, but that doesn't prevent us from using it as a then step or a when step. The first argument after given, when, or then is a regular expression. That's the thing that Cucumber is going to try to match the step against. It will look at all the step definitions it knows, and by the way, it is an error for more than one of them to match. So it'll find exactly one step definition where that regex will match, maybe including capturing some of the arguments. Those captured arguments, if any, become arguments to the block, and the block can do anything it wants. But typically, things that it will do include making calls through Capybara or into your Rails app to make stuff happen. Why would a step fail? And we'll do a little live example of a step def in a moment here. There's two different ways a step can fail. There's kind of a good way it can fail and a bad way it can fail. The good way it can fail, if you can take my meaning for this, is there's a type of step, typically when you're writing a then step, which is checking post conditions, like the last one where it said, then I should see the name of the movie on the home page. The way that we write those steps includes having assertions in the body of the step def. An assertion is basically declaring your expectation that something is the case, and if that thing is not the case, and then we say that the assertion has failed, and that causes the test to fail. Now, I say that that's a good failure because it indicates that your code is doing something, it's just not doing the right thing. The other way a test can fail is that there's an actual exception, like your app blew up. So if the user enters, blank for the movie title, and your test forgets to check that blank is not a valid value, that would be the first kind of failure. But if the user enters blank for a movie title, and as a result, because you have no error checking in your app, the app actually throws an error trying to enter a blank movie in the database, that's kind of a bad kind of error. That's like a type 2 failure. Your app not only didn't do the right thing, it didn't do anything defensible, like not sensibly. Okay? So there's at least two ways that a test can fail. So we had been doing little demonstration scenarios with Cucumber, which lets you write out these nice stories that, given, when, and then. And we saw that Cucumber kind of makes use of this library called Capybara that you can think of as it pretends to be a browser. In fact, it has all the logic built into it that a browser has, including how to do JavaScript. It just doesn't give you a visual indication like a browser of what it's doing. But it's manipulating all of the same data structures internally. So Cucumber's job is to match steps and step definitions. We saw how regular expressions are used to put those together. Capybara is what we call a headless client or a headless browser. It can parse HTML pages. It can initiate interactions with those pages. So in every respect, from the application's point of view, it looks like a real client. In our setup, the way it works is that there's an adapter called racktest, which allows Capybara to interact directly with the rack app server running on your computer. So everything in this stack here is one process. And this will become important for reasons that I'll show you in just a moment. But within one single process, you're running your Rails app against the test database. In front of your Rails app is the rack app server, as always. And then driving interactions through the rack app server is Capybara, possibly driven by Cucumber. When we start talking about other kinds of testing, we're going to add RSpec, which we're going to use for writing unit and module tests. And the reason that I pointed out that all of this is occurring in the same process is there's another scenario that you can use to test a staging app where they're in different processes. This is a scenario where you still use, for example, RSpec or Cucumber with Capybara to stimulate the browser, but now you actually are using a different piece of software that fires up an actual real live web browser, and you can actually see it doing all of the things. And that web browser can interact with a remote site. In fact, it can interact, for example, with a site that's deployed in a staging environment. So this is kind of an additional level of testing that is not quite production, but goes pretty far beyond what you would do on your own computer. Right? So this is kind of our world of testing stacks. And like I said, this is the stack that we've been demoing so far, where everything along the red line is running in a single process, where we've got steps, we've got a library that interacts with the app server, and we've got the real live copy of the app running against your test database. Okay, so that's the orientation of where we are. And we reviewed sort of what are the main moving parts, the skills that come with writing Cucumber scenarios. The first one is the steps and step definitions, right? So steps are the sort of stylized language in your file of what's going on, given when and then. Step definitions are the actual code that makes each of the steps happen. So we saw an example for something like, given a certain movie exists in the database, the step definition that implements that would probably do something like use an active record create call to make that movie exist, right? So making, basically, the step definitions make the test step do what it says it's going to do. We saw some simple examples, and I'll show some more today, of how to identify and interact with the different controls on a page. That's Capybara's job. One big trick that we'll see is using CSS to find and name elements. So for example, on a typical complicated page with lots of buttons, lots of different divs, a very useful trick is when you're creating that page, give IDs to the elements that you're going to want to use in your tests. Because if you've got, a table of movies and every single movie has a delete button next to it, and you need to write a test that says when I click the delete button for a certain movie, then that movie should be deleted, wouldn't it be nice if the element you want to identify in your test has some unique way of naming it? So I'll show you some examples of that as we walk through. My hope is we'll walk through a couple of real scenarios from a real app, and you can see how they look. And then finally, checking the output, the post conditions. The most common type of post condition in a Cucumber scenario is going to be either something that looks at the page, because from the user's point of view, when a certain set of interactions happens, their window into the app is what is being displayed in the browser. And you can also have expectations that look directly at the database. So a good system level test might actually do both things, right? It'll check that the page says movie whatever was successfully created, but it might be wise to also look in the database and make sure that that's really the truth. Because you can imagine a type of bug where the movie didn't get created for some reason, but the message still gets printed out. In a real application where the scenarios are maybe a little more complex than what we just saw, and a few different features of Cucumber that let you deal with those. So here's an example of a real Cucumber scenario from a real app. This particular app has about 150 scenarios scattered across like 40 or 50 different files, which is sort of typical for a medium-sized app. Let me show you the actual app that this scenario is written for, and then we'll walk through the scenario steps. We'll look at the step definitions, and you can get a sense of how some integration testing issues are addressed in real life. So this is the staging version of the app in question, if it loads. And by staging, I just mean that it runs in the same kind of conditions and environment as the, let's see. There we go. It runs in the same environment as the production version, but it uses fake data and it uses a whole separate database. So the feature here is someone who's like a manager in a theater updating profile information about one of their customers. I'm going to pick a random person. By the way, all of the names and addresses in this thing are fake. There's a great gem that generates fake names, addresses, and emails and things for you so that you have realistic looking data. And you can see that if I go into this sort of editing screen, the customer can update things about their profile. There's also these things that are sort of shaded in yellow. These are things that only managers and administrators see. The customer doesn't see them themselves. And what I'm testing here is the ability to change staff-only comments, labels, blacklists, and other things like that. So you can see some of the basic steps that, given I'm logged in as Box Office Manager, that's important because that's the only way that I, as a logged in person, can make changes to someone else's profile, right? So a precondition for anything to happen here is I have to be logged in as someone with privileges, and I have visited the edit contact info page for a particular customer. So what happens, and by the way, why are these steps called background? You can see that this file has two different scenarios: change staff only comment, blah, 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 and changing customer's role. The background steps are preconditions that apply to all of them. So when Cucumber runs these, it will execute all of the background steps before each of the scenarios, right? So it's a way of pulling common preconditions out that apply to multiple related scenarios. So how are these things actually implemented? If we look at, first of all, let's run it and make sure it passes. It should, because I haven't, there we go. Sorry, I got to make the window a little smaller so you can see everything. OK, so if I just run this single file of stuff, this is going to result in two scenarios being run. OK, so there's the title of the file. And green is good, right? Sorry, my windows aren't wide enough to make this work really well. So here's the two background steps. And you'll notice that for each one, it is kind enough to print out which step definition actually matched that regular expression. So when I go to debug my tests, I can actually see what they matched. So let's take a look at what a couple of these might do. When I visit, let's take a look at the login steps. Okay, so there's a lot to unpack here, and as usual, the goal for you is not to understand every line of code. It's to sort of try to understand the high-level floor plan that I'm trying to explain what's going on. So how do you make true the step definition of given I'm logged in as a Box Office Manager? What's the sort of implied precondition to that? Like to say, a Box Office Manager is a kind of user, so clearly that kind of user has to exist, because if they don't exist, you can't log in as them. So actually what the first thing the step definition tries to do is it uses what's called a factory, which we're going to talk about next week after the midterm, to immediately create a customer, a patron record, that has the privileges of a Box Office Manager. Once that customer has been created, and the way that that logic works is it creates them with a fixed password, because this is a test, so we don't care. And it finally calls this little helper called verify successful login, which actually is basically a script. It goes to the logout page to make sure that there isn't like a residual somebody previously logged in. Then it goes to the login page. Then it fills in the email and password fields, and it clicks the button. So in this case, it's actually doing the exact thing that a real user would do. The only difference is before trying to log in that user, it had to create them. Why? Because the test database starts out clean with absolutely nothing in it. So every piece of information you need for a particular test has to be created somewhere along the way for that test, and then it gets incinerated after the test is done. As you might expect, there are a lot of shortcuts so that you don't have a tremendous amount of code in every single test, but this is the general flow. Okay, so that kind of takes care of the first one. I've created someone who's a Box Office Manager through a create method that I haven't talked about, but trust me, it works. And then I've actually gone through the literal steps through the web user interface to make that person log in. And then the next step says, I visit the edit contact info page for a particular customer, myself. So again, what is being implied in that line? It says, I visit the edit contact info page for customer Armando Fox. That assumes that there's a user named Armando Fox. Otherwise, there's no way to get that step to work. So you can see where I'm going with this, right? Something about that step definition is probably going to say, if there isn't already a customer named Armando Fox, then please create him. By the way, why might there be a customer named Armando Fox in the test database? given that I just told you the test database always starts out being empty? Why would the step definition for something like that second step be able to check whether maybe the customer already exists? How might the customer already exist in this case? Sir?
Don't we see the database?
So one possibility is that you seed the database beforehand, but suppose you hadn't even seeded the database. Why might it be the case that sometimes in a step def like that, the named customer might already exist?
You might have had it before.
I might have had a previous step that created him, right? So, or another way to look at it is further down here, like let's skip down to this step. After a bunch of things are done, then customer Armando Fox should have the following attributes. When this step definition runs, the customer named Armando Fox will already exist because he was created up there. So some of these step definitions have to be written in such a way that if the customer exists, great. If the customer doesn't exist, then just create one that has the required name and get on with your life, right? So we'll see a mechanism called factories that makes this really easy to do. Basically, it says, look, all I care about is that the customer have that name. I don't care about the customer's other attributes. Just make one and just make it be a legal person. The only thing I care about is that the name matches, right? So there's software that will let you do that. Yes?
So going back to the
Given? Yes.
box office manager, the step definition like goes through the steps of logging someone in. So then isn't it reliant on the login part working? Like even though in this case it's a precondition, so it shouldn't.
Yeah, that's a really good point. So the question is, given that my implementation of step definitions for logging in actually are using the real flow and visiting the real pages, that implies that if that part of the logic in my app is not working, then any scenario that tries to do login this way will also fail, and that is absolutely right. And there is kind of a chicken and egg problem here, because sometimes before you can write a test, you have to have a minimal amount of stuff working so that you could even write the test, and that's exactly what you're observing here. Now, the real reason, and I'm going to make a confession here, I'm going to go public and say this, is that this scenario was written, and don't kill me, it was written after the code to implement login had already been done. Now, my only defense for this is that I was young, it was many years ago, I was under the influence of substances, whatever. I wrote the login and logout code, and I sort of tested it the bad old way, which is like by typing in a web browser, like, oh yeah, seems to work. And once it seemed to work, I was like, great, now I can use it in all of my scenarios. Don't do what I did. Okay, it was 2008, it was a crazy time. The revolution was brewing, and I probably just, I didn't know what I was doing. I would do it differently today. But yes, well observed, that in this case, I'm relying on the app logic to actually do this. Okay, I'll do like a few more. We don't have to walk through the whole scenario, but I want to give you a sense of, oops, where'd the scenario go? What's going on here? When I interact with a bunch of stuff on the page, and as a reminder, here is what that page looks like. So there's a bunch of things I can fill out, like email, address, et cetera, et cetera. I can select the birthday here. But basically, once I have done these things, notice that I've identified myself as a lush. I don't know what I was thinking when I wrote this scenario, but whatever. The post condition says, then I should have the following attributes. And there's like this nice little table thing. So a long way to do this would have been, you could have a bunch of steps of the form. Then Armando Fox should have the comments attribute equals lush, and Armando Fox should have the blacklist equals true, and customer Armando Fox should have blacklist equals true. But that would be extremely boring to read, and it gets us farther away from what is trying to be tested. So in this case, I had the good taste to use what's called a cucumber table. Basically, let's go to the step definition that does that, and cucumber is telling us that that's at customer steps RB 104. Okay, so what am I actually trying to do here? In my somewhat convoluted step definition, the first thing I'm doing is I'm capturing the first and last name of the customer. Find customer is a shortcut method that I wrote that will actually find this person, and hopefully it will. And then basically, using a syntax which you do not need to understand in detail here, but I want to show you how it works generally, I'm essentially walking through the table. What I'm getting back is a bunch of hashes where each hash is a row of the table. Let me make it so you can see the rows again. Okay? So you can see that the table columns are called attribute and value. And basically all I'm doing is for each attribute and each value, I'm just checking that the appropriate attribute of the customer, don't worry about the typecast stuff, equals the name of that attribute. So the important thing in this example is not this code, which is a little bit tricky. It's the idea that you can tablify certain kinds of information. That gives you a shortcut of expressing, I have a bunch of values and a bunch of keys, and I just want to make sure, I want to kind of do a mass check on all of those. I'll show you a slightly nicer example that doesn't rely on some of this weird, I had to sort of work around something Rails does here, so don't worry too much about that. Let me try to show you one other example of a Cucumber scenario. Tabular data, that's a good one. Let's see. Is that one? No. There we go. OK. So again, I want to give you a few highlights of a more complex scenario, not so that you understand every line, but to give you a sense of what these things look like in real life. Here's a scenario for refunding an order. So someone has ordered something, and for whatever reason, they want a partial refund of it. So I've got a couple of different scenarios here. And you can see that I basically have one scenario that refunds the whole order. I've got a different scenario that only refunds certain parts of the order, and the scenarios are checking different things. But of course, in order for testing refunding an order, you first have to have an order. And if you have an order, that means that you have a person who made that order. So you start to sort of see how your preconditions have to get set up, right? And indeed, my background is basically a bunch of steps that ensure that there's a customer and the customer is placed in order. Because we got to be specific, we got to pick a name of a customer. It looked like I chose to pick tomfoolery this time around. And I have a step that basically has another example of one of these tables. So the step definition for this is, you can imagine, is going to march through that table and do some amount of work to make it be the case that Tom gets all those items added to their shopping cart, and Tom eventually purchases that order. And now you can imagine, as you're starting to write this, you think, OK, well, gee, if Tom is going to add tickets to see Chicago on that date at that time, then the assumption is, what are the assumptions? What assumptions does this given step with its table make? What's going to have to be done somewhere in the test code? What has to exist in order for this step definition to even be a thing? Yes?
The show?
So the show, so it implies that there's a show set up in the system called Chicago, that it has a performance at that particular time, that date. It also implies that there's a guy named Tomfoolery, and that he has managed to buy tickets to all these things. And then look at the very next step. I'm logged in as box office manager. So that's an assumption. There has to be a box office manager, and they have to log in. We already saw how that's done. And finally, once all that background is set up, there's a page where the box office manager can see all the orders for that person. In fact, I can show you what that page looks like so you can tie the test to reality. Here's an example of that page for some fake customer in our staging database. Orders. Okay, so this is an example of the kind of screen that only the box office manager sees. And you get the idea of how the interface works, right? Like if I check some items and I click cancel checked items, then they get a refund, et cetera. But this is the user interfacey version of what this is trying to test, right? So, and then the last thing I want to call your attention to is things like stub successful refund, stub successful credit card payment. Again, when we talk about the details of how you write these tests, we're going to go into how those work. But what's going on here is that if you were using the real live site, the act of paying for an order involves doing a credit card transaction, because that's how you pay for things online, right? And in the real site, I don't know if you guys have heard about Stripe, which is basically an API for credit card payments. The real site makes a call out to Stripe to say, please charge this person this many dollars. Obviously, when you're running tests, you don't want to be calling Stripe and trying to do credit card payments. Even though Stripe has an excellent API for testing where you can provide like fake credit card numbers, you don't want to be hitting the Stripe server every single time you run the test because you could be running it hundreds of times during development. So there's basically some separate logic in another file that says, for these tests, when the call to Stripe happens, just cut it off. Return a fake value from the call as if Stripe said that it was successful. Because that's not what the test is about. We just need to make that behavior predictable in a testing environment. Okay? So what I'm trying to do here is kind of give you a grand tour of what these features look like in real life. It's not too much of an exaggeration to say that if you can do something manually in an app that has a web interface, then you can automate that thing in one or more tests using this kind of setup. And yes, you're going to find that sometimes it feels like you're spending more time trying to get the test to work correctly than trying to write the code. It's going to feel like that. Trust me, because every time I sit down to do more work, I often feel like, gosh, I wrote the code. I know the code works. Why is it taking me a long time to get the test to do the right thing? What you forget is how valuable the tests are, because once you've written it, you have it forever. And every time you make a change to anything in your code base, you can run all of your tests and ask yourself, did I break anything? And it's really, really nice to know that at least as far as the tests that you have created, you haven't broken anything. So yes, it takes a long time sometimes. Sometimes it feels like it takes too long to get the tests to work the way they're supposed to, even when you know the code works the way it's supposed to. But the reason to do it is now you always have the test, and it's permanently part of your test suite. It's documented. So in fact, if I forget how refunds are supposed to work, I can actually just read the scenario, and I can remind myself what the user interface is like, right? I can use this to even explain to a new box office person how they should do it. So have some faith, hang in there. The very first few scenarios that you write with Cucumber are going to seem very painful, but hang in there because it gets easier fast. In particular, as you write more scenarios, you start to develop more and more steps in your sort of step definition vocabulary, and you end up needing to write less and less new code per test. You end up reusing some of the step defs you already had. Okay, so stick with it. It's going to feel weird. I know it's like it hurts when I do this, but if you do it enough, your arm will stretch out, and then you'll get good at it. Okay, so that's a high-level tour. There's a lot of machinery here that you haven't seen yet. We will sort of get into it as we talk more and more about how to write these kinds of tests. But I wanted to give you a sense of what the scope of these things is like. And I hope that I've done that to some extent. So a few pitfalls when you're writing these Cucumber scenarios. We saw that there's the difference between a happy path and a sad path. The happy path is sort of when the customer or the client or the user does everything right. They do everything the way you expect, and the software behaves the way you expect. But that's usually not enough to say that the story is done. The way that your software reacts when something goes wrong is equally important. So covering the sad path in your test is usually part of marking the story finished. Also, be careful when, sometimes it's appropriate in some of these tests. We saw examples of when such and such a thing happens, then I should not see something on the page. And usually when you write that, your intention, for example, here's an example of, the user deleted the movie called Emma, and you might say that when they revisit the list of movies, they should not see Emma on that page. Makes sense, but remember that if your app gives an error or visits the wrong page or does something completely unexpected, that step will still pass, right? So be very careful with negative expectations. They only tell you what you don't expect to happen, but there's many, many ways that your app can make a mistake, and usually only one way that it can be right. So if you're doing stuff like this, make sure you're also including positive expectations or positive assertions to check the results in the database, to check whether there are other things on the page that at least will give you a signal that it's the correct page, right? Like if it's really the list of movies page, okay, maybe you should not see this movie, but there are other movies that should still be there. So including those positive expectations sets some additional confidence that your test actually is testing the thing that you think it's testing. On the other hand, you also have to be careful, even with positive expectations, because especially if you see something like, then I should see some string, and there's some situation in which that string might appear multiple times on the same page. For example, this is sort of contrived, but using a word like and or the, then I should see the word and. Well, the word and probably occurs a million times. So if you're not careful about how you phrase these, sometimes the test might pass, even if, in fact, the functionality is not correct. One of the examples, which ironically we used in the exam code, is that there's a helper in Capybara called within that lets you restrict searching for a particular element or text on the page to be within some CSS selector. So when we talked very briefly about HTML, we remembered that there's HTML elements and there's also containers like divs and spans. A very common testing technique, in fact, one that I use all the time, is when I'm designing my pages, my views, and the pages are sort of made up of different sections, I make sure to give each section a unique ID in HTML just so that I can name it in a test later on. So for example, if I have a part of the page that's where the shopping cart is shown, I'll just give that the ID shopping cart because now in a test, I can refer to it specifically and I can narrow down expectations to only examine that part of the page. Right? So again, it's really about making sure that when you implement the test, they're testing the things that you think they are. So my hope is that a lot of you are getting to the point in the project where you are finding it necessary to write some scenarios that are sort of non-trivially complex. You've probably figured this out, but Capybara can do a lot of stuff. But it's a pretty complex power tool. And a really good way to get a sense of what it does is to look at if you're inheriting a legacy code base, look at the step definitions and the Cucumber scenarios that are already there to give you a sense of what's possible. But here's a few sort of generic power user tips that you may find useful as you're trying to develop your scenarios. Seeing what Capybara sees. So sometimes you'll write your scenario saying fill in this with that, fill in this with that, and then I should be on some page or I should see something on some page, and it'll just fail. And what you want to know is, okay, well, I said I should see X. If you didn't see X, can you tell me what you did see so that you could figure out where the bug is? There's a gem called launchy, which I think might actually be included by default in the gem file if you create a new project. I'm actually not 100% sure. But if it's not, you can certainly add it. And don't put it in the production group, just put it in the test and development groups. If you include that gem, it adds a new method in Capybara's namespace called save and open page, which is super, super cool. Because if you call save and open page, it will save a static HTML representation of the page and pop up a browser window. And then you can see the page that Capybara was seeing at the moment that you called save and open page. You also get, with the standard websteps.rb that is one of the gems that we sort of recommend that you seed all new projects with, it defines a step definition called then show me the page. And the only thing that step definition does is it calls save and open page. So if you're developing a scenario and you can't figure out why the scenario is not working the way you expect, and all you're getting is the error message from Capybara that your assertion failed, use the launchy gem and actually see what Capybara is seeing, and then you can view source. I mean, you could do everything that you could do if the page was live in the browser, because it does in fact open up in a browser. A really, really common reason that things like this happen is, for example, if you get to the point in your app where now you're about to add the idea of logging in, now all of a sudden you might have some scenarios that don't work anymore because they now require, or they assume that the user's logged in before they can get to that point. So all of a sudden you had scenarios that were working, and now you have to add some, instead of getting to the page you thought you were going to get to, what you're actually getting to is a page that says, sorry, you have to be logged in, or something like that. So the launchy gem is your friend for things like this. In order for it to work, though, you have to be doing development on your local computer. So if you happen to be doing Cloud9 IDE-based development, I don't believe they've gotten this to work in Cloud9 yet, for reasons that have to do with how they implement app serving. But I can't survive without then show me the page. If you Google the obvious terms, cheat sheet with Capybara or RSpec Rails, there's a zillion cheat sheets out there. But what they boil down to is that the magic object in Capybara is this thing called page. Page is a method that's defined everywhere in all your step definitions, and what it returns is a representation of basically a top-level HTML element that supports these really great things like find. Like you can say, find me the page element or elements whose CSS descriptor is this. So this would be an element whose ID is some div. If you know how to use XPath, XPath is this much more complicated XML representation for navigating the elements of an HTML page that lets you burrow down and say, look for an H1, and then inside the H1 look for a paragraph, and inside the paragraph look for a tag that has these attributes. The syntax is a little bit hairy, but XPath can find anything. Now, as I think I mentioned early on, a really good habit to get into when you're designing your HTML views is if you think that some part of that view is going to be useful in a scenario for testing, give it an ID or a class that is easy to find. So if there's a page that somewhere on the page there might be a place where an error message is displayed, and if you're going to write a Cucumber scenario that is going to look for, does the error message have the right text, give the error messages div some obvious ID, and then you can just say in your Cucumber scenario, tell Capybara, find the element whose CSS matches that, and then you're done. Okay, but if you haven't done that, or if you're dealing with legacy code that hasn't done that, XPath is a fallback. So how can you use these? You could say, expect the page to have a CSS element matching something. So for example, going back to my, if you're showing an error message, the error message presumably should only be there if the error condition occurred. So you might have a scenario that's really just checking when the error condition is stimulated, does the box containing the error message actually show up on the page? You could use something like this. In general, I know that in the early examples we had this stuffed up, then I should see, quote, some string on the page. As we mentioned earlier, it is really easy for that to give you false positives, because all it's doing is checking whether the string occurs anywhere on the page. It's not constraining it to, is it within a certain part of the page, or does it occur more than one time? So there's a reason that the gem that provides these things is called Cucumber Rails training wheels. The training wheels should come off as soon as possible, right? And you should find yourself writing step definitions that are much more precise in what they're actually looking for. So this is one way to do that. There's also, you can do a little bit of Googling about this as well, but you may have noticed that if you have pages where you're using the default Rails form helpers for things like doing dates, the date dropdown is actually 3 dropdowns, right? There's like a month, day, and year, and you'd like to be able to say something like, when I select, January 1st, 2010 as the whatever date, as opposed to saying, when I select January from month and 1 from day and 2010 from year. So there's a number of gems out there that basically add step definitions for Cucumber and methods in Capybara that make it more graceful to deal with stuff like that. In particular, if you find yourself using things like JavaScript libraries that do like those nice little date picker pop-ups that have multiple months, usually those will come with, or you can Google and find a separate gem that will let you say something like, when I choose whatever from the date pop-up, and it will do the right thing in Capybara, and you don't have to sort of go step by step for each of the subtasks. I think I mentioned that one of the projects is actually working on a code base that I own. Some parts of it I'm embarrassed by, and other parts I'm pretty proud of. But it does have hella Cucumber steps. So if you're looking for examples of doing things like dealing with tabular data, you got a table of data that shows up on a page, and you want to find out whether the table has a row containing some entry. There's a bunch of code that shows you how to do that. There's entries about passing state between steps, which is really useful. So for example, if I have a sequence of steps that is aimed at selecting a particular performance, in my later steps, I want to say things like, and I want to buy a ticket for that performance. It implies that somehow the step knows what I mean by that performance. So there's examples of scenarios where instance variables in the Cucumber step defs are used to pass state down, so you can make references like that. Time travel, super, super useful. If you have any features you're trying to test that where you're testing a behavior related to the time or the date, there is a gem called TimeCop that basically lets you fake the clock that is seen by your application. You can make it be a particular day. You can move forwards and backwards in time. And that lets you consistently write scenarios that will always be operating under known circumstances. So if you've got something about leap years, you can first set the clock to February 29th of a leap year, and then do whatever test you're supposed to do. Related to that is, again, you can see some examples of this in my own code base and somewhere else, but there are tags that you can apply to scenarios saying, only for these kinds of scenarios, set up some certain conditions. So for example, in my app, I have a number of scenarios that actually do depend on the date, because they make assertions about things expiring and stuff like that. And then I also have a lot of scenarios that have nothing to do with the date, so it doesn't matter. The ones that depend on the date have a tag, and related to that tag is a little piece of code in the env.rb file of Cucumber that says, when a scenario that has this tag is run, do these steps first. And in this case, the steps are, it uses TimeCop to set a date that is always the same for every scenario in which time matters. So if you've got scenarios that depend on something, right? Related to this is if you give the tag at JavaScript. Some of you may already have discovered this or been forced to discover it. Capybara actually has a JavaScript engine inside it. So if you've got JavaScripty features on your page, like when you click on a button, it reveals a pane or causes a dialog to pop up, you can test all that stuff. But turning on JavaScript for Capybara is very expensive in terms of performance. So if you tag a scenario with @JavaScript, it will fire up the JavaScript engine, and it will be ready to do any kind of testing related to those interactions. If you leave that tag off, then actually you'll get a static page. So if you have pages whose proper behavior depends on having JavaScript turned on, and we'll have a lot more to say about JavaScript in about 2 weeks, make sure you say @JavaScript in front of those scenarios, or they will fail to run. This is a few examples, but like I said, the best way to learn about what you can do with Cucumber and Capybara is find a code base where you can look at the step defs. The website that I'll put the link up again, but it's the website that has links to all the repos for all previous CS169 projects. The step definitions you'll find there are of varying quality, but you'll get a sense of what is possible.